Aha! The heat of this water is 35 degrees Celsius. The temperature is not too hot, nor is it too cold.
Now, you've got heat and temperature mixed up. Can you tell me the difference between heat and temperature?
Let me see.
Oh well, let me save you the trouble. How do you measure temperature?
With a thermometer.
What is the unit of temperature?
Degrees Celsius.
Correct. So in other words, temperature is a measure of how hot or cold something is.
Okay, now how do you explain heat?
Well, heat is a form of energy. Heat is the amount of energy that is needed to make something hot.
I don't quite get it.
Okay, let's say we boil 2 cups of water. Cup B contains less water and takes a shorter time to boil, while cup A takes a longer time to boil. Since heat is an energy that makes things hot, what can you conclude from the above experiment?
Less heat is needed to warm a smaller volume of water.
Bingo, you are right. Since cup A has more water, more heat is required to warm up a larger volume of water. Okay, now you've a firm grasp of the terms heat and temperature. We shall soon see the direction of heat flows.
Huh?
Take a look at this setup. I have a metal rod with drops of wax along it. Now I am going to place this end of the rod above a burning candle. Now check out what happens.
The drops of wax are melting.
Yes. Let's use another new rod, but this time we place the candle on the right instead.
The wax melts too.
But did you realize that the wax also starts to melt at one end of the rod?
Oh, I realized that. It always starts melting at the end where the candle is.
This clearly shows us that heat flows from a hotter place to a colder place. Okay, let's take a break and enjoy a cup of hot tea. Take a look at this cup of tea.
Nothing's happening.
Well, we can't see it, but it sure is happening. Remember that heat travels from a hot place to a cold place?
Oh yes. So the cup of hot tea is actually losing heat to the surrounding because the surrounding is colder.
Yes, but if we wait longer, the temperature of the cup of tea will soon decrease till it reaches the same temperature as the surrounding.
Just like when I place water into a freezer. The water will lose heat to the surrounding till it becomes ice and reaches the same temperature as the freezer.
Yep, that's right. Heat not only travels from a hot place to a cold place, it also flows till it reaches the same temperature as its surroundings. Remember, when we are learning about the 3 states of matter, we know that when ice gains heat, it will melt. Let's carry out another experiment. We can see that the temperature of ice is about 0 degrees Celsius. Let's wait an hour and see what happens.
The ice has melted.
Yes, the ice gains heat from the surroundings and melts. Note the temperature of the water.
It's about 15 degrees Celsius.
Well, when ice gains heat from the surroundings, what happens to its temperature?
Oh, the temperature rises.
Yes, heat gain and heat loss goes hand in hand with temperature. When something gains heat, it becomes hotter. Naturally, its temperature rises.
It's the same when I freeze water. It loses heat and its temperature drops.
Yep, you've got it. We are always playing around with the effects of temperature in our daily life. When our soup is too hot, we wait for it to lose heat before we drink it. When our soup is too cold, we heat it up. We are in fact waiting for the soup to gain heat. What are some effects of heat loss that we deal with daily?
Formation of ice requires heat loss. Oh, heat gained during tanning can be lost with a dip in a pool.
Yeah, you're right. What about the water cycle?
Oh yes, heat is gained during evaporation of water to water vapor. Heat is lost during condensation of water vapor to water droplets.
Heat gain and heat loss occur around us at all times. This supports life on Earth. Heat is a form of energy. Energy can change into different forms, but it will never disappear.